Welcome back to another one of my implicit differentiation videos. I'll be showing you how to implicitly derive equations, and we will then therefore find an equation for the tangent line on a graph of a certain point. Okay? So basically we're going to have a graph. It's going to have our y, it's going to have our x, and it's going to look like the infinity sign. That's bad, it's supposed to be in symmetry, but I'm a terrible drawer. Okay, so the point we're looking for is here. That's going to be 3, 1. And the equation is going to be 2x squared plus y squared all squared equals 25 x squared minus y squared. Okay, now I got this out of the James Stewart calculus textbook. The people who wrote it is Sengage Learning. Oh shit! Either that G is silent or it's not. But yeah, I got it out of that. We got our question is here, and it's called a lemniscate. Oh shit! And so we're going to find the point. Going to find the point here and use that to help us solve for the equation on a tangent line. Okay, so let's start by deriving both sides. I'm just going to do this in quotation marks to signify that I'm doing the derivative of above. Okay, so let's start by bringing the power down. So it's going to be, the derivative is bring the power down, make it 4 x squared plus y squared. It's going to be the power of 1 because we take the power off. Then it's going to be multiplied by the derivative of the inside. The derivative of x squared is 2x multiplied by dx over dx, because that's the derivative of the inside, plus 2y multiplied by the derivative of y, and that's going to equal, I'm going to expand these out here, so we'll have it's going to, over here it's going to be 25 x squared minus 25 y squared. Okay, so to derive that, we're going to have 50x multiplied by dx over dx minus 50y multiplied by dy over dx. Okay, so we're going to expand these out, and we're going to get 4x squared plus 4y squared, 2x plus 2y dy dx equals 50x minus 50y multiplied by dy dx. Now's the point where we sub in our coordinates. We have 3 and 1. 3 for x and 1 for y. Therefore, we're going to have 4 multiplied by 3 and square it, plus 4 multiplied by 1 squared, 2 multiplied by 3 plus 2 multiplied by 1 multiplied by dy dx equals 50 multiplied by 3 minus 50 multiplied by 1 multiplied by dy dx. Okay, That's going to come out to 40. And inside the brackets, we're going to have 6 plus 2 dy dx equals 150 minus 50 dy dx. Expand this out further, we're going to have 240 plus 80 dy dx equals, it's just going to still be 150 minus 50 dy dx. Okay, what I'm going to do is get all the dy dx on one side and all the others on the other. So we're going to have 80 dy dx plus 50 dy dx equals 150 minus 240. What we're going to get is 130 of dy dx's equals negative 90, which in turn we're just going to write as a neat fraction of negative 9 over 13, because negative 90 over 130 is the same as negative 9 over 13. And that will equal Rm, because our derivative is the slope, therefore m is the slope, therefore negative 9 over 13 is m. Now we're going to sub that into some trusty equations of y minus y1 equals m multiplied by x minus x1. Everything with a subscript of 1 is going to be a coordinate. So we're going to have y minus the y coordinate, which is 1, equals m, which is negative 9 over 13, multiplied by x minus x1, the x coordinate is 3. So therefore we're going to have y minus 1 equals negative 9 over 13 multiplied by x, plus, because we have a negative multiplied by negative, 27 on 13. And we're going to end up with y equals negative 9 13x plus 40 on 13. Because we're going to bring the 1 over and add it on. And if we're adding 1 on, that's when you're working with fractions, the denominator is 13. So 1 is the same as 13 on 13, because that equals 1. Therefore, we add it on, and adding 13 to 27 will give us 40. Anyway, that is our answer. Equation for the tangent line. Now, thanks for watching this video. I hope it helped, and I hope you have a good day.